Chapter 4, Strong Acid, Strong Base, Class Life Science. Part 7, Titration, Strong Acid, Strong Base. At the end of this session, students should be able to master the pH metric study of the reaction between a strong acid and a strong base, perform the pH metric titration of strong acid, strong base. Part 9, Titration, Strong Acid, Strong Base. Introduction. The titration is a technique where a solution of known concentration is used to determine the concentration of another solution of unknown concentration choice. During titration, a chemical reaction occurs between the solution of unknown concentration and the solution of known concentration. The reactant of solution of unknown concentration is called titrated reactant or analyte. The reactant of the solution of known concentration is called titrant or titrator reactant. Part 1, Equation of the titration reaction. Let's study the titration of hydrochloric acid solution H3O plus Cl- by a sodium hydroxide solution Na plus HO- are the following given. Hydrochloric acid solution of unknown concentration Ca. We take a volume Va equal to 1 milliliter. We titrate the solution by sodium hydroxide solution of known concentration Cb equal to 10 negative 2 mole per liter. The volume of base added at equivalence is determined during the titration. The ionic equation of the reaction between hydrochloric acid solution H3O plus Cl- and sodium hydroxide solution Na plus HO- is H3O plus Cl- plus Na plus HO-. Here, the reaction takes place between H3O plus and HO-. H3O plus is an acid, it's the donor of H plus. HO- is a base, it's acceptor of hydrogen ion H plus. Then H plus is transferred from HO plus to HO-. H3O plus becomes H2O and HO- becomes another HO, then we obtain 2H2O. Na plus and Cl- remains Na plus and Cl-. Then we obtain 2H2O plus Na plus Cl-. Cl- remains Cl-, Na plus remains Na plus. These are spectator ion or indifferent ions. Then the net equation, Cl- and Na plus are indifferent or spectator ions. The net equation of the reaction is H3O plus HO- give 2H2O. The characteristics of this reaction are complete, fast, unique, and exothermic. Procedure. We have two types of titration. Colorimetric titration, that means using a colored indicator to identify or to detect the equivalence point, and pH metric titration. Now we will see the procedure of colorimetric titration. This is the setup. We need magnetic stirrer, beaker with its magnet, graduated burette, and the solution used to be to titrate the hydrochloric acid, which is an NaOH solution. First step, withdraw or take 20 ml of hydrochloric acid solution using 20 milliliter volumetric pipette with pipette filler. Introduce this volume into a beaker of capacity 100 milliliter containing a magnet and place it on a magnetic stirrer. Add 2-3 drops of bromotrimal blue solution. Bromotrimal blue is a colored indicator that gives yellow color with acid solution and the blue color with basic solution. Here we have hydrochloric acid in the beaker, then the solution becomes yellow with bromotrimal blue. Rinse gradually the graduated burette, first using distilled water, then using the solution, sodium hydroxide solution, and after that we fill it with the sodium hydroxide solution of concentration Cb equal to negative 2 mol per liter, 10 negative 2 mol per liter. Add the basic solution from the burette progressively now till the color in the beaker changes from yellow to blue. This is the last point added and the color of solution changed from yellow to blue is the equivalence point. Note the volume of the basic solution added at the equivalence VBE. Consider the level of solution in the burette becomes here. Then this volume is the volume added, which is called VBE, volume of base added at equivalence. Now this video shows the colorimetric titration of hydrochloric acid by sodium hydroxide solution. Here we have the magnetic stirrer, beaker, graduated burette. We rinse the graduated burette using distilled water. Then we rinse the burette with the sodium hydroxide solution. Then we fill the graduated burette using the sodium hydroxide solution till the graduation 0. Now we use a beaker containing a magnet. We take a volume of capacity 20 milliliter of the sodium hydrochloric acid using a volumetric pipette of capacity 20 milliliter with pipette filler or rubber valve. Introduce this volume into the beaker containing a magnet and place it on the magnetic stirrer. Now we add 2-3 drops of the bromotrimal blue solution into the beaker. The solution becomes yellow. The color changes from colorless to yellow. We start the magnetic stirrer. Then we add the sodium hydroxide solution from the burette progressively till the change of color from yellow to blue. The last point added and the color changed to blue is the equivalence point. Now the last point added, the color changed into blue, and we note the volume at equivalence. A change in color at equivalence. Here we have hydrochloric acid solution with bromotrimal blue with yellow color placed on magnetic stirrer. When we add the sodium hydroxide solution drop by drop, the place where the drop with the solution, the color change to blue. The last point and the solution becomes blue is the equivalence point. Then the change in color from yellow to blue at equivalence. From yellow to blue. Then we note the volume added at equivalence. This is the procedure of colorimetric titration. Now, pH metric titration. This is the setup of pH metric titration. The same setup, graduate burette filled with sodium hydroxide solution, beaker containing hydrochloric acid solution, magnetic stirrer, magnet. But now we use a pH meter to measure the pH of the solution during the titration. We introduce we put the electrode of the pH meter in the solution to measure the pH at each step of the titration. The procedure is: first, withdraw 20 ml of the hydrochloric acid solution using 20 ml volumetric pipette. Second, introduce this volume into a beaker 250 ml containing a magnet and placed on a magnetic stirrer. We calibrate the pH meter to measure correctly the pH. Then we rinse the electrode of pH meter with distilled water. We dip the electrode of pH meter inside the solution into the beaker. We add distilled water to the beaker to immerse the electrode of pH meter, because the 20 ml of hydrochloric acid in the beaker are not sufficient to immerse the electrode of pH meter. Then we add distilled water, and we will see later that this addition of distilled water will not affect the result of titration. Measure the pH of the solution in the beaker before the start of the addition of sodium hydroxide solution. When the volume of base added equals 0, we measure the volume, the pH of the solution. Now we rinse the graduate burette 50 ml with distilled water, then with the sodium hydroxide solution, and then we fill it with the sodium hydroxide solution of concentration Cb equal 10 negative 2 mol per liter. Add the basic solution 10 ml from the burette, 10 ml after 10 ml into beaker. Then measure the pH corresponding to each addition. When the pH starts to change more rapidly, we add the basic solution from the burette 1 ml after 1 ml or 0.5 after 0.5 into the beaker. Then we measure the pH corresponding to each addition. When the pH changes slowly again, we add the basic solution 2 ml after 2 ml till the end. The total volume of base added is 30 ml, 25 ml, according to the case. This video shows the pH metric titration. This is the setup of titration. Inverse support, graduate burette, beaker containing the solution with distilled water, and the magnetic stirrer. First, using 10 ml volumetric pipette, we take 10 ml of the solution, of the acid solution, using 10 ml volumetric pipette with pipette filler. We add magnet, then we add distilled water to the beaker in order to immerse the electrode of pH meter. This is the electrode of pH meter. We dip it into the beaker in the solution. At this step, we prepare a table to note that when VB added is 0, we note the pH. pH equals 3.8. We record or we note the pH at each instant. Now we add 1 milliliter. After addition of 1 milliliter, the pH becomes 4.1 milliliter. Then we add another 1 milliliter. The pH is 4.29. After addition of another 1 milliliter, that means the volume becomes 3 milliliter, volume of base added. The pH becomes 4.45, and so on. For 4.6, 7, 5.1, after addition of 10 milliliters, the pH becomes 9.04, till we add a volume of 20, 25, 30 milliliters. After 14, then pH equals 10.5. This is the procedure of pH metric titration. At the end of titration, we obtain a table containing the obtained data from this titration are given in the following table: volume of base added in milliliter and pH. The data of this table are different than the data obtained from the video. Then we obtain the table like this. Then this is an animation that shows the pH metric titration. We have magnetic stirrer, beaker, electrode of pH meter and pH meter, the graduated burette, and we have a graph. We will draw the graph directly from the result of the titration. When the volume of base at 0, the pH is, this is pH initial. When we add base, pH increases. The pH first increases slowly, then we pH increase rapidly, and the curve makes a jump of pH. This is the jump of pH. After that, the pH increases slowly again. Till the end of the titration. Now, the glassware needed for titration and the role of each one. There are 3 glassware used in acid-base titration. Volumetric pipette of capacity V milliliter to withdraw V milliliter of the solution to be titrated. For example, if we need to titrate 20 milliliter, we use volumetric pipette 20 milliliter. Beaker of capacity 100 or 250 milliliter to realize the titration of V milliliter, 20 milliliter of the solution to be titrated. The reaction of titration takes place inside the beaker. Graduated burette 25 or 50 milliliter to add the titrating solution. Application 10, Plot the curve pH equal function VB representing the table 1, the data obtained after pH metric titration. Take the following scale: 1 cm for 2 ml in abscissa, 1 cm for 1 unit of pH in ordinate. Solution of application 10. This is the curve representing the pH metric titration of strong acid by strong base. In abscissa, the volume of base in milliliter. In ordinate, the pH. We see that the pH increases slowly first, then increases rapidly, and the curve for a jump of pH, then the pH increases slowly again. Using this graph, we will see how to determine the equivalence point in the next video. This is the end of first part, procedure of titration.